Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. Hey, what's up everyone? TWIML Fest, our virtual AI festival, has now come to an end. Spanning 3 weeks, 40 sessions, and 74 speakers, it was an amazing experience and a testament to the incredible and talented members of the TWIML community. I want to send a huge thanks to everyone who helped make this such a great event. We hope you enjoyed it, and if you missed any of the sessions, you can find them at twimlfest.com or on our YouTube page at youtube.com/TWIMLAI. Be sure to subscribe while you're there. TWIML Fest is now behind us, but the mission continues. We've already started gearing up for TWIMLCon AI Platforms, our Enterprise MLOps conference, which takes place January 19th through 29th of next year. For more information on that, visit twimlai.com/TWIMLCon and sign up for updates. Before we jump into today's interview, I'd like to thank S&P Global Market Intelligence for their support of the show. S&P Global Market Intelligence is a division of S&P Global, a leading provider of credit ratings, benchmarks, and analytics in the global capital and commodity markets. S&P Global Market Intelligence integrates financial and industry data, research, and news into tools that help track performance, generate alpha, identify investment ideas, perform valuations, and assess credit risk. Investment professionals, government agencies, corporations, and universities around the world use this essential intelligence to make business and financial decisions with conviction. If you're a data scientist working on applications in the finance space, I encourage you to visit the S&P Global Marketplace at www.marketplace.spglobal.com and explore premium fundamental and alternative datasets available seamlessly via cloud, feed, and API solutions, along with robust data solutions and expert analysis. One last thing, if you're in the States, you know that tomorrow is election day, and this election could not be more important. If you have not already, please get out and vote. And now, on to the show. All right, everyone, I am super excited to be here with Frank Zhao, Senior Director of Quantitative Equity Research at S&P Global. Frank, welcome to the TWIML AI podcast.
Hi, Sam. Hi, everyone. Thank you for having me. I'm delighted to participate.
Awesome. It is super exciting for me to have you here. One of the topics that comes up all the time in our community is finance, and in particular, how folks that are learning machine learning or practicing machine learning can apply some of what they're learning to making money in the stock market. It comes up all the time, and we don't cover it nearly enough on the podcast. And this is what you do every day. So I think folks will be interested in hearing what you've got to say on the topic and the way you are applying NLP in particular to some of these opportunities. Before we dive into that topic, though, I'd love to hear a little bit about your background and how you got started working at this intersection of finance and machine learning.
Sure. Like you mentioned, I do quantitative equity research. And the way I like to kind of explain it is quantitative equity research is data science plus domain knowledge. In this case, equity investing. I've been in my current research-oriented role for the past 8+ years. And in the past 3 years or so, we've diverted more resources to extract investment insights from non-numerical data sets. Such as natural language, audio, and images. My work particularly have been focusing on extracting investment insights from earnings call transcripts. How did I get into kind of this space? I think part of it is my academic background. I have computer science, economics, and financial engineering degrees, and I always wanted to be at the intersection of leveraging computers, but do something that's business and finance kind of related. And so for me, this is the path of least resistance, and I couldn't be happier, doing what I do.
That's awesome. So You started to hint at what you and your group is focused on, but maybe tell us a little bit more about the specific focus that you and your team have at S&P Global, and I guess tell us about S&P Global. I think everybody knows, S&P, at least from the perspective of the index, but tell us more broadly about what you're focused on there.
Sure. So the team that I am part of, we're within one of the four kind of divisions, which is called market intelligence. And with market intelligence, I think that we kind of provide predominantly financial markets related cutting edge analytics and then kind of data. Now, the research group that I am part of, I think the closest analogy would be to a sell side investment bank equity research group. And I will say the main difference is that instead of having soft dollar arrangements, what we have is we write or these empirical publications, and then in exchange, our clients, institutional investors, purchase analytics and data sets from us.
Okay. So sell side investment bank research, they're typically researching companies, stocks, and writing reports about those companies and their expected future performance. And that analogy applies to you in that your group is doing similar things, but based on natural language processing and other machine learning technologies. Is that what you're saying?
Yeah, that's kind of correct. So, typically there are two types of kind of main schools of investing. So one is, fundamental oriented, where the analysts take a very deep dive into the financial statements, where, they kind of know a handful of stocks very intimately. And whereas quantitative stock investing, which is what I do, where, we look at a portfolio of hundreds of stocks and then trying to leverage computers and statistics to make a robust kind of forecast. Now, in the past kind of several years, we've kind of starting to do a lot more data science and machine learning kind of work. I think part of the reason is that our clients are increasingly paying attention to non-numerical data sets, such as language, audios, and image, like I mentioned, because some of the traditional data sets from, let's say, financial statements, I think a lot of low-hanging fruit have been kind of picked. Now they're increasingly, trying to differentiate themselves, see if they could come up with more sort of newer investment insights.
Got it. So let's maybe dig into some of the specific projects that you've worked on to, get a better sense of the way that you apply data science to this challenge. Can you walk us through some examples of the kinds of things you're doing?
Yeah, so absolutely. So we have kind of published an NLP paper series. There are three papers, focusing on earnings call transcripts. And, earnings calls are basically these periodic calls that are held by the executives at publicly traded firms. And it is public to everyone, where the executives review their latest financial results, as well as kind of discuss some future projections, as well as perhaps new product launches. Now, in order to kind of understand and extract investment kind of insights from these transcripts, we applied NLP. So we've done three empirical publications first. So first, we wanted to kind of introduce the NLP data science topic to our institutional clients who are very quantitative, but may not as well versed in data science. So we did a primer, which is the ABCs of NLP, where we trying to talk about the what and the how. And also we made available about 400 plus lines of Python code, where our clients able relatively quickly to use the Python code to do some basic NLP analysis on the transcripts.
If I can just jump in there, I think what is subtle but amazing in just where we are in machine learning is that, you can give someone 400 lines of Python code and have them do something meaningful, even though, maybe it's an example and it's not going to give them kind of the trading edge, but you can give them a meaningful example of things that they can do with NLP on an equities research or in these financial transcripts. Can you give us an example of what they were able to do with the examples you provided?
So within that kind of Python code, we are trying to come up with a number of predictive analytics. And they broadly could be categorized into two buckets. One is sentiment based. So we end up actually leveraging very comprehensive predefined dictionary in the context of business and finance. There's some existing literature where it says domain-specific dictionary has a lot more efficacy and power. The other broad category of predictive signals is what we call transparency scores. So the idea there is to quantify the level of transparency that firms provide via executives' direct and subtle actions and behaviors. So one example there may be the language complexity. So the intuition is as follows, that we think when firms are doing really well, that it is in the best interest of firms to provide maximum kind of transparency. And even the toughest questions, in our opinion, could be explained simply, directly, and succinctly. I think it is when things aren't going as well, whether transitory or otherwise, executives perhaps may increase their language complexity by using more polysyllabic words or use more, complex sentence structures to soften the bad news via obfuscation.
The triple negative. With these examples, can you talk a little bit about the techniques you're applying? Is it, are you doing kind of bag of words and, looking for frequencies of complex words, or are you doing more advanced things, embeddings or word to vec, or what's the general approach you take, both in this, the simple example that you provided to your clients in this ABCs paper, but more broadly in your work?
Sure. So actually kind of both, progressively we layered on more complexities. So I think initially it was a bag of words. It's simple, but yet it's very transparent and intuitive. In the context of equity investing, that's actually very, very important. Just there are many estimators, especially on the unsupervised side, they tend to be a little bit more kind of opaque. We've also kind of used sort of more advanced sort of techniques. So in our latest publication from end of January of this year, one of the things we did was sentence level processing, where we systematically identified a number of market moving topics, as well as their surrounding neighboring descriptors, to figure out, what financial related topics that are market moving that the executives are discussing, and how do they feel around those topics, whether the firms are accelerating their revenue, or whether they're expanding their margin. We've also kind of used some techniques that are within kind of data science. So one of the things we did in our latest publication is coming up with various weighting schemes, to create a weighted average sentiment scores, as opposed to, say, a simple average construct. So for instance, TF-IDF, a term frequency, inverse document frequency, which is a concept from informational retrieval. Another example may be, measuring language similarity using, for instance, cosine similarity, basically converting the text between two pairwise calls, into a list of kind of numbers, and then, measuring the geometric angle between the two vectors. Smaller the angle, the language is more similar. If the angle is wider, it's more dissimilar.
I'm imagining there that you might look at transcripts that resulted in a big stock price increase and use that as a label and try to find, for a new transcript if it's close to that? Does that kind of thing work? Or is it, are you looking at the cosine similarity for, more granular types of insights?
That's a great question, Sam. I will probably say it's kind of closer to kind of the latter. I think there are a lot of similarities between data science and quantitative or systematic research. I will say one kind of difference is that within quantitative research, we actually spend a lot of time thinking about the economic intuition. For instance, why firms that exhibit more positive sentiment, why they should historically outperform and why they will continue to outperform, or why firms display a higher level of transparency, why they should kind of historically outperform. More often than not, we don't train specifically to future stock returns, just because within the space, the signal to noise ratio tend to be very low. Where your signals, if you train it that way, your signals may have very, very unbelievable predictive power, where you're just minting money. But once you take your signals to data that the methods haven't seen, they kind of quickly decay to noise.
It also brings to mind some of Nassim Taleb's Black Swan and resiliency, robustness, that kind of thing. If you're just trading on kind of back-tested signals, you really have no fundamental robustness to changes in the future.
Right. So exactly. So I think one of the really interesting and challenging things about the financial markets is dynamic. Every year it tend to be kind of self learning. So I think economic intuition and robustness is very, very sort of big in our field. I think the most important thing is when you're trying to come up with these signals, you want to making sure they will work into the future. So from that sense, data science, NLP, there are more tools, perhaps to do a better signal constructions to extract newer kind of insights.
Yeah, I think all of this speaks to the relationship, maybe the tension between kind of data science as a tool absent of domain expertise and the role of domain expertise. And you're making it pretty clear that it's not about just kind of throwing tools willy-nilly at these earnings transcripts and using those to generate signals, but more that data and tools that can extract information from it in the hands of domain experts, becomes really useful. Can you talk about the relationship between domain expertise and data science in your work?
Sure, absolutely. Great question. And you're absolutely right. And that's why, I feel like one of the things, even within the data science domain, that is very popular is feature engineering. Basically, applying data science tools and estimators, within the context of your industry or the problems that you're trying to kind of solve. Now, the way I kind of see it is that we're starting to have convergence between data science and systematic or empirical research. So my view on it is empirical research has been around since the mid 1950s with the Nobel laureates Harry Markowitz, his thesis, modern portfolio kind of theory. And then in the late 70s, the investment community to really kind of embrace statistics and computers trying to extract meaningful insights that are void of human emotions. Now, in the past 10 plus years, as you know, there's this proliferation of data science. And I think one of the main reasons, with that is firms that are outside of investment management are starting to embrace and quantify, data points to make more informed decision. Now, in terms of investment management, in the past kind of couple of years, there have been some literature starting to explore, machine learning kind of tools that typically that systematic equity researchers haven't used. Perhaps one of the reasons is due to opaqueness, such as neural network or deep learning. But I think the more traditional statistical methods and frameworks, perhaps there may be some saturation. So one of the things, market participants, institution investors, they're trying to differentiate their predictive signals and analytics by embracing some of these newer techniques, see if they could come up with more differentiated, actionable insights.
What I heard there was on the one hand, you've got these traditional statistical techniques that have been well studied for many years in finance, and it's kind of the nature of finance that anything that's well studied and well understood is not differentiating because it's kind of the cost of entry. Everybody knows how to do that, and everybody does it, at least at these your top tier clients. And then on the other hand, you've got newer techniques like deep learning that are more opaque, but also not just more opaque, but because they, in a lot of ways, take care of the feature engineering as opposed to allowing data scientists to do feature engineering. They distance the domain expertise. It's not just opaque. We talk about deep learning as opaque usually from the perspective of you can't see inside of it and you don't understand why the decisions are being made. But you're also raising an interesting point, which is it's harder to influence it and apply domain expertise. Is that what you're getting at?
Yeah, I think you're absolutely right. So I think there are kind of two things come to mind. So one is that I think the part that's important is I think the supervised kind of learning, supervised neural network or deep learning. I think there's definitely a kind of a place within investment management, and I think investment management is kind of going in that direction. We're kind of starting to kind of embrace it, where there's more transparency, where the researchers, their intuition get to drive the modeling as opposed to the modeling kind of driving the research. I'll also say is I think the second kind of part is with the kind of the deep learning. I think when you have kind of enough layers, I think it's kind of hard to kind of disentangle exactly why certain features are being generated or why are certain kind of weights sort of assigned to it. But nevertheless, I think supervised neural network. I think in the next couple of years, I think the investment community will have some breakthroughs.
So where does that leave you in your desire to apply your domain expertise in this deep learning kind of future?
Sure. So I think the domain expertise is kind of still important in the sense that I think you still need to kind of figure out what kind of the inputs are that have economic underpinning to kind of feed kind of in there. And when the weights that are sort of moving between the layers, as well as having the outputs, you could try to do a bit of reverse engineering and trying to figure out why this information is kind of additive and it may be different from some of the traditional statistical methods that you're kind of using. So I would say within data science, many of the supervised methods, I think empirical quantitative researchers have been using for years and even decades. I think the part that's unsupervised, I think that's kind of relatively new to the community. And then once we have a better understanding, a more intuitive feel, I think perhaps there will be some new insights we could extract from there.
So walk us through the process of doing what you do, delivering what you deliver. Your final deliverable is ultimately a publication that a client is consuming about some either individual equity or a set of equities.
Yeah, that's correct. So I think in terms of kind of research, part of the group is it kind of culminates in a empirical publication. And the closest example would be these research papers that you see that are published by finance professors, where the steps kind of involved is initially we start with economic hypothesis. We think firms whose executives exhibit more transparency or exhibit more higher positive sentiment, why they should historically outperform. And then, from there, we go look for the data sets that are kind of relevant, that hope that we're able to empirically test out our hypothesis.
And
Now,
is this only earnings call transcripts or audio, or are there other data sets that you are fusing into your earning call focused pipelines?
sure. In terms of myself, the research has specifically kind of pertained to earnings call transcripts. But in terms of the frameworks and kind of capabilities, a lot of it may be applicable to sort of other data sets. And then you could always, once you distill down the signals, let's say from various data sources, you could sort of combine them in an intelligent way where the composite signal is even more powerful than the individual ones.
Got it. So you've collected these data sets, in your case, primarily transcripts. I've got to imagine that your challenge is like most other data scientists, and that the data is not pristine and you have to do some work to get it ready for your pipelines and your modeling.
That's such a good question and observation. Yes. And I will probably go even further in the sense that when it comes to kind of investment, empirical kind of research, I think our requirement for the cleanliness and pristineness of the data perhaps is even kind of higher. For instance, there's kind of a saying where you're not sure about your input data set, then doesn't matter how compelling the results are, you have less sort of confidence in them. So a lot of biases, we try to be very, very mindful of. So for instance, a look ahead. What that means is making sure that you're not using a data, in your backtest that was not available in the public domain when at that particular point, when you're assessing your strategy or building your portfolio. You want to mitigate survivorship bias. What that means is if you ever look at the performance of all the firms and constituents, let's say a US market right now, such as Amazon and Apple, your performance backtest will be spectacular, right? Just because they are the survivors, they're the winners. So, we also kind of want to be vigilant in that.
And in addressing those kind of biases, are there tried and true techniques that you're applying, or is there research and innovation that is happening to help you avoid those kind of biases?
Uh, I think kind of both, but I think it will be kind of more the former. So, for instance, to mitigate the look ahead bias, one of the innovations within the investment community that we came up with is something called a PIT, a point in time. Basically, be able to kind of capture various data points with a timestamp that's down to the seconds. So such that you have a time series of snapshots. In terms of survivorship kind of bias, your typically investment professionals have a mandate. It is the universe they're able to operate from. So, for instance, my mandate is U.S. Large kind of caps. So, for instance, in this case, maybe we may use Russell 1000 or S&P 500 as a proxy. So S&P 500 constituents change over time, and as long as you have snapshots of those, you could sort of mitigate the survivorship bias.
So you've cleaned your data. You have your hypothesis. You've sourced your data, cleaned it up, and then you're doing your analysis, building your models. And we've talked a bit about the modeling process, or at least a few examples. Anything you'd like to add on that step of the process?
Yeah, I'll just add. So when we kind of get there, we use a variety of frameworks and tools that we have in our repertoire, and then now, including what's available within the data science kind of toolkit. I think relative to kind of the data science kind of endeavor, I think within empirical equity research, not only you need to come up with something that's robustly kind of predictive, but also it needs to be additive to the existing signals and models that are people using out there, which many have been perfecting for years and even decades. And so the data science sort of analogy I like to use here is that it is not enough to come up with an omni search, but you have to come up with an omni search that is, incrementally better than what people are using kind of, currently. And, as you could sort of tell, kind of over time, the bar gets higher and higher.
What's an omni search?
Oh, like kind of typing in your kind of search box, and then you actually complete words and phrases and so forth.
Got it. So that's just an example of you can't just do something that is already done. You have to make it better.
Correct, and not only better, it needs to be additive. In the sense that, let's say, people are using these sort of these kind of signals, and your new one need to, once it kind of get it added in there, it needs to kind of improve, let's say, your forecasting power, or or mitigate your risk, or a combination of thereof.
Okay, got it. So I imagine then one of the big challenges that you have to deal with, and one of the, if not the next step in the process, is evaluation. How you evaluate the results or the models that you've created or the analysis that you've done. It's already come up indirectly in talking about things like look ahead and survivorship and things like that. But what's the general process there? You mentioned that you can't just, backtest everything. It's got to be a little bit more sophisticated.
Kind of great kind of question. So, for every, potentially a new signal or kind of strategy, practitioners, we actually look at like a multitude of metrics or statistical sort of metrics to gauge its kind of efficacy, and to kind of ensure whether they're all kind of painting a very similar kind of story, speaking to its kind of robustness. So, for instance, one statistical popular estimator is Spearman correlation. Basically, it is a proxy for signal strength, where we kind of take a look at how stock level signal values at time t, how well they measure up or correlate to stock level kind of forward returns at t+1, where t could be say monthly or quarterly periodicity.
Okay, so again, similar question to the one I asked earlier. Are you primarily applying tried and true evaluation metrics and techniques, or are there unique things that you need to develop as you're innovating in the modeling and the data pipelines?
Sure. So I think, in terms of gauging the efficacy of a signal, I think there is a set of measures. Myself, as well as our institution clients, they kind of look at. They're pretty domain specific. I think a lot of the innovation is coming in more about using the new tools and kind of frameworks within kind of data science to see, how to extract more meaningful information from non-numerical data sets, as well as to see, able to kind of capture some additional information. So, for instance, one of the things we've been exploring ourselves is, leveraging a neural network, trying to capture some of the more non-linear relationships that potential signals may exhibit.
Along those lines, talking about tools and using the tools, I'd love to hear a little bit about your experience there. Are you developing your own tools? Are you primarily using off the shelf tools? What does your kind of stack look like there?
Sure. So I would kind of say most of it are more proprietary libraries, and then most of the heavy lifting, for instance, with the transcript work, they are done in kind of Python. We do leverage a little bit of the pre-built libraries, but most of them are, things that we have full transparency kind of over, for instance, within NumPy, calculating something kind of very simple. In that case, we won't reinvent the wheel. Now, in terms of the more, sort of sophisticated frameworks or estimator, so for instance, like a neural network, at least my personal opinion is the best way to understand, have the best intuition why things are moving the way they do is to build from scratch. So, in this regard, we probably will leverage less TensorFlow initially, and we'll actually build everything kind of from scratch. And once we have a much better intuitive feel, then perhaps we'll leverage some of the things in TensorFlow, for instance.
Yeah, it's pretty interesting. What that says to me is in another type of organization, the thing that they might be optimizing on is efficiency and getting some result or prediction. But in your business, the thing you really need to optimize on, or one of the things that you need to optimize on, beyond efficiency and performance of the models, is understanding. And the way to drive the most understanding in the process is to just build it up from the bottom.
Absolutely. I think when it comes to it, everything else being the same, I think we place the most weight on economic underpinning and intuition, just kind of transparency, because we want to know why the signal is overweighting these type of stocks in the portfolio and then underweighting kind of other. And in fact, I think, most, if not all, of my very sophisticated institutional clients, those are of paramount importance to them as well.
And you'd think that a neural network is, essentially kind of a commodity, but when you really start to play with it, you can get very different results based on very obscure things that are deep in the bowels of your framework, like the way it, some default parameter or some learning rate or, something like that. And so if you don't know that inside out, you don't really understand the decisions that the models are producing. That's what I'm hearing is your perspective.
Yeah, so in fact, that kind of connects really well with one of your earlier kind of questions. Why in many ways is awesome. I'm starting to see a lot of brilliance in kind of the neural network. Why there is and always will be the importance of kind of domain expertise, and I think I, as well as others in the space, will always see neural network more as a tool. And the second point I want to kind of make here is it's kind of funny you kind of mentioned. I think data science will like to talk about hyper parameters. Basically, how one set up their architecture within neural network. I was actually just having this discussion, several weeks back with some of my colleagues. I was like, within neural network, there are so many user, defined, parameters, number of layers, number of nodes within each layer, the loss function, a learning rate, and so on and so forth.
So on the model side, the estimator side, you're kind of building that up from scratch. And I'm curious, like C++, or Python, you don't necessarily have a low latency requirement, do you?
No, I think not in this particular case. So everything is kind of within Python, and I think probably with the infrastructure, progressively as we work with these more CPU intensive frameworks and algorithm, we want to leverage cloud computing kind of a lot more.
Yeah, that was my next question. Was beyond the models themselves, what are you doing in terms of building out scalable pipelines? Have you built or do you use any particular tooling to help your researchers manage experiments or access training data or collaborate?
Yeah, so absolutely, I think all of the above. So for instance, one of the things we have the accelerating of growth of unstructured or non-numerical data sets. There are so many of kind of them. But I think part of the investment is you're not sure which type of data sets will give you incremental additive investment insights. So one of the larger corporate level initiatives that we have had is called a platform marketplace, where we have these many of these alternative data sets are kind of on there, where the user are able to very quickly to visualize the data, to have a better understanding of kind of the data and see if it may be complementary to some of the ideas and workflows they have. Another thing that we're kind of embracing is recently we announced JV with collaboration with Snowflake, where basically you have the internet, where it's a very intuitive UI, and so for instance, our clients could very quickly leverage Snowflake and be able to kind of access all this vast trove of data points.
Meaning, so Snowflake is a cloud-based data warehouse that is very popular. And what I'm thinking you're saying is, well, two things. Your earlier comment was you don't know what data set's going to be additive, so you have to collect everything and make it easy to explore. And two is you're then exposing all these data sets that you've collected or some subset of them to your clients using some Snowflake compatible interface.
Exactly. So, one interface, and then, it gives the optionality of clients, kind of using different, cloud kind, storage. So giving them that kind of optionality. And then, our clients no longer need to store a lot of these data set, on their end. And plus, Snowflake, one of the things that's embedded in there is you could kind of pay for usage or kind of speed.
Well, maybe to wrap things up, I referenced the broad interest in this topic in our community earlier. For those folks that want to take the next step in applying machine learning to equities trading and finance, what do you recommend? Either as kind of hobbyists or folks that want to get into it professionally.
Sure. So, I will kind of say, there's so much kind of, open source kind of tools out there now, with Anaconda and Python. And then there's so many sort of, some data points are kind of out there, whether you're thinking about making a transition professionally or just kind of doing it kind of more kind of leisurely. I think there's no substitute for just kind of being hands-on. My recommendation would be to pick up on a kind of some domain-specific kind of books, and then just kind of implement it. And if time permits, implement them from scratch, and then kind of test it out. Many platforms have paper trading accounts.
Got it. So start with imaginary money and not real money. And I would have guessed that you would have said make sure that you understand some of the fundamentals of investing as well, and develop your own economic hypotheses. Is that something that you would recommend?
Yeah, sort of, absolutely. Think about sort of the main drivers of, the equity markets. In the very short term, it could be a random walk. It could be very kind of noisy. But, I would say in general, especially the equity asset class, after about 40, 50 years of, very rigorous kind of empirical research, I think on a monthly and, or longer horizon, a portfolio of stocks are, at least in my opinion, are forecastable pretty kind of, robustly.
Awesome. Well, Frank, thanks so much for taking the time to chat with us and share a bit about what you're up to.
Yeah, thank you very much for having me. Thank you.
All right, everyone, that's our show for today. To learn more about today's guest or the topics mentioned in this interview, visit TWIMLAI.com. Of course, if you like what you hear on the podcast, please subscribe, rate, and review the show on your favorite podcatcher. Thanks so much for listening, and catch you next time.